let us start our topic today, which is electrostatics. It is made up of two words. They are two Greek root words. One is electron, and in the modern language it means amber. So amber is a gem which is used in jewelry. And the other word statics. It is also a Greek root word which means statikos in Greek. And in modern language, if you see in English, we can say it means at rest. So if we combine these two words, we are talking about electron at rest or amber at rest. Now, what amber has to do with our chapter? Let's see. In ancient Greek, amber was noted to attract small piece of papers. Imagine that you used to do that in the childhood. You used to rub your comb with your hair, and then it was starting, attracting small pieces of paper. Similarly, they also found that we were not the first one to discover that, and they thought that it is due to this amber or electron, and it was kind of magic. But later on, scientists got to know that it was not due to only amber; it was due to the charges in amber. So Greeks were upset about it. They thought, we thought electron was doing some magic, but the modern scientists, they told no, it is about the charge on amber. When you were rubbing with a cloth, at that time it got charged, and that's why it was, attracting small piece of paper. But because the ancient Greeks, they were getting sad, so they assured them, okay, wherever such phenomena we will see, we will use the same name. So still now, if you see the word electricity, we use the electron reference, which is referring the amber. Now, there are many properties which we can understand. Like, for example, we know that like charges repel. If a negative is there, then they will repel each other. Positive will repel each other. They don't want to get together. They want to go far away. And the attracts opposite. They want to get together. So this is one of the property of charges which we already know from the previous classes. So there are other properties also which we will go through one by one. First thing is additivity. Like we can add them with signs. The fancy word for this is additive nature of charges, and it says that we can add them algebraically. Algebraically means take care of the signs. So if you have 2 coulomb charge, if you add minus 2 coulomb of charge, the net charge will be 0. Similarly, these two problems also, 3 coulomb minus 2 coulomb, net charge is 1 coulomb, 3 coulomb plus 3 coulomb, the net charge is 6 coulomb. So we can calculate net charge by this principle, this property which we have just learned, which is called additivity. For example, if you take any atom, it has one charge in the nucleus and one electron. Say it is a hydrogen atom. It is neutral. Why we say it? Because if you calculate net charge plus E minus E, it become 0. So the additive principle we use when we are dealing with charges. So this is the first property. The second property is we cannot create charges, or we cannot destroy them also. We can only transfer charges. Take an example, like if this atom has gained one electron, so it must have come from somewhere else. If you see, this atom has lost one electron, that's why it has got one. You cannot create electron just like that. You cannot destroy it just like that. This electron has gone here. We can only transfer charges. Now we can say this atom has gained one electron, so net charge will be minus E. Think how I'm calculating this. I'm using an additivity principle, and this has lost one electron, so the only remaining charge is plus E, which is of this proton. It is like similar analogy when you have a friend and you give him money. Like for example, you give him 3 rupees, and afterwards, you come after 2 days and he says, "Oh no, it was 2 rupees." So you will say, "No, no, it was 3 rupees. How it can be gone? You must have given it to someone else. You must have transferred it. It cannot be destroyed. I have given you 3 rupees. It must be with you." Or you must have spent it somewhere, you have given it to somewhere. So that is how the similar analogy we can use with the charges also. So this is the second property. So here is another property which is we call quantization. Quantization, you can think of small packets. So here are the small packets which are available. These are the minimum charges available in the world. Like the charge on the electron and proton. The value of magnitude is 1.6 into 10 to the power minus 19. Okay, so if there is a box and it has charge, it can be 15e. You can count them. It will be 15 multiplied by small charge. It cannot be fraction, because you cannot break this electron and make two charges of zero point 0.8 zero point 0.8 say. You cannot do that. That is not allowed. So any charge, if it is there, it will be only integer multiple. So 15 is an integer multiple of E. It cannot be a fractional multiple of E. It cannot happen. This violates our quantization property. Quantization means the minimum charge available is only this much, 1.6 into 10 to the power minus 19. Now it is very difficult to say this charge again and again. So we write a shorthand for it. We say it E, we represent it by E. So this is the magnitude, the minimum charge. It is a shorthand writing, and we call it elementary charge. Elementary word you can relate it with the elementary classes. So elementary is basic, small classes. So that is you cannot go lower than that. So similarly, we call them elementary charge, so that you cannot get lesser charge than them. Minimum is E. You can get 2e, 3e, 4e, 5e, but you cannot get 1.2e. That violates our law. So if you see an electron here in this atom, so it will have minus e, negative elementary charge, we can say. Electron is negative elementary charge, and the charge on the proton will be plus e, which will be positive elementary charge. And the net charge will be on this atom will be zero. It will be neutral. Why? We can do additive principle again. Plus e minus e will be zero. So that's how we are saying this charge will be neutral. Okay, this another analogy is like think of a shopkeeper who only gives apple in minimum pieces of one. So he will say, I can only give you one. If you want four apples, yeah, four apples are allowed because they are integer multiple of one apple. So I can give you 4, 5, 6, but if you ask me 3.5 apple, I will not break one apple into two pieces and then I give it to you. Similarly, we cannot deliver charge less than 1.6 into 10 raised to power minus 19. We cannot break electron and say it has two charges, zero point 0.8, zero point 0.8 you can take. That is not allowed. So this property is called quantization of charges.